That's the minimum. It should be saying. Okay, maybe not because it's still returning that. Before that. There's the best minimum set to. And then returning the actual critical point minimum. Minimum reached. Initialize H direction to the left. We're still going to the left. But it's not toggling the type. Yeah. Next type, next extreme is toggle to maximum. So now we're going to look for a maximum. Crash. Code not implemented, but that means that it's thinking. It's telling me that it's in the middle. The in the middle. Okay, so adding minus 12. Pending to history. Update approximation, add 12. But it just updates the scale, which doesn't really update anything. Again, approximation. Calling a handle approximation, and that goes wrong. I don't get this at all. Let's just put a breakpoint here, I guess. Condition 1, W is less than minus 12. Less than minus 12. Is that less than minus 12? W underscore. Okay. Adding minus 12. What the F does first call mean? What is the very first call to approximation, I guess? So we already have an approximation. This thing is big. Cubic. Cubic is already initialized. Yeah, okay. Well, I probably also should see that we have samples. But it's not being printed, I think. Samples. Stored in a container D vector. So you don't see that, you just see the buffer here. I do see that we have 5 or 6 elements in it. Okay. No, that was short fun. Scientist. Last reading is already set. I need to figure out where that is being set. So this is inside handle approximation. I think it was already set before that then. Where would that be set? Yeah, it should be set in the call to find extreme, which is called from where. I have no idea. Can I set a break on find extreme? Again, amazing. Let's run this again. It's called from update approximation. Okay. Well, among others, maybe it's also called from another place, I'm not sure. So let's continue. No idea when to stop. I have a W here. Okay, so the moment that this is minus 7.65 space. Damn it. Oh, type 2 spaces. Continue. Find extreme. Going to do up and then print W. That is the critical point. Yeah, probably one more. Handle approximation with minus 12. You're got to be kidding me, right? Yeah. The last time we stopped in breakpoint 2 was here. And at that moment, W was the critical point. So I have to wait until we get here. Let's run it again. Continue, space, continue, space, up, W, it's not yet, continue, space, up and W. So that would be this point. Next. Okay, so the minimum is at -7 3/4 and maximum is very, very big. But more importantly, extreme type is still minimum. Yeah, that's why it's going to return in between. So this is going to return in between because the minimum is in between, I don't know, 2 points. This is a slightly larger, so slightly more negative, slightly on the left of the actual critical point. Oh, we're talking about parabolas here. What? Okay. Square root of d is almost equal to c. Coefficient is one of the coefficients of the cubic. Therefore, this cubic is almost equal to a parabola, which is totally correct, of course, because we are fitting a parabola. You see, this is the parabola, and it just lays on top of it. And then somewhere here we have a maximum, like billions to the right, but yeah, that's not really interesting. So it's saying, okay, this is like a parabola. And then I think this should be unequal. And then it sets the extreme type to unknown. Yeah, of course, because so if you're looking for a maximum, this should be a maximum, but the cubic looks like a parabola, and that parabola only has a minimum, so we don't know. That's the unknown then. We don't see a maximum. So what is wrong here is that extreme type is not equal to maximum. It's set to a minimum, which is not correct, I think. Okay, because it is a minimum, we just continue here, get here. And that then sets region out to in between. Because the vertex of, well, the critical point, or in this case the vertex of the parabola is that. And we have a point on the left which is that, and a point on the right which is that, and well, the thing lays in between these two. Okay, so the question is, why is this extreme type equal to minimum while I had expected maximum? That's line 200 of, it's like this. So extreme type, where does this come from? That's just a function parameter. It's a reference to a variable that was passed second argument of find extreme. So next extreme type is minimum, and in the debug output we saw somewhere that it printed, toggled it to maximum. At the very least, that's what I remember. So let's highlight this variable. I think that was like literally in the debug output. Nope, last thing printed is minimum. Is a toggle to maximum? When does that happen then? That happened just before we return minus 12. So that should happen in handle local extreme minus 7.75. I don't see it. Maybe I didn't get there yet. Surely should have gotten there. What was the last thing that was passed? This one? Here's the handle approximation. Yeah, there it is. Angle approximation minus 7.75. But did not toggle the minimum yet. Minimum to a maximum apparently. I'm looking for where it says minimum found. Also don't see that yet. What the hell was it? Quilt. Are you kidding me? I did all this effort, creating a oracle expression thingy. Oh, I did it in a different. Okay, never mind. Did it here, so I have to run it here. So minimum is passed here in call to find extreme before minimum is reached and the next extreme is toggled. That is why it is not working. Aha. Aha, aha, aha. The can of worms has been found. Oh man. Sure. I think I have to call it again. This must actually be correct, right? I mean, I'm just calling new, or calling find extreme, and then we get a new W. And then maybe that new W is based on that value. We decide that we did find the minimum. In which case I would need this call. Let's put a breakpoint here. Let's put a sensible breakpoint. If something debug attach GDB, something being that my current W is, there will be W there. Wait. To W, but I don't know how to access the thing. Wait. Did this cause it to a double, I guess? No. Returning in between goes to, etc. This returns there. That returns the critical point. To minus 7.5 here. Well, it returns the minimum. So the next extreme type is still minimum here. Find the minimum. Yep, and it returns where that minimum is, which is here. And then the question is this new W going to be used to determine that we reach the minimum? That we actually reach it? State is extreme jump. Okay, going to jump to an extreme. So step is very small now, very small. Hi Kivo. Yeah, well, I'm using a cubic, but if the I have a parabola here, and I'm fitting a cubic on it. So the result is, of course, a cubic that looks very much like a parabola around this region, and then still has a maximum somewhere. But that maximum must be ignored because it's probably just nonsense. So if the cubic looks too much like a parabola, then I'm assuming that it is a parabola instead of a cubic. So indeed, well, we did not make any significant step here. But I already knew that. Where's my keyboard? Design it. Expected LW. Ah, there it is. Indeed. So we take the absolute value of the step taken. Print it. It's very small. And then based on that, we decide that we reach the value. We reach the minimum, sorry. So the next extreme type is a minimum still. Therefore, you want 5 times more accuracy. But we have that anyway. So now it prints the minimum reached. And then we're going to toggle to the state becomes local extreme. Return true. To true from what? Handle approximation. And then here we handle the local extreme. Aha. You can which function did call the find extreme? Was that not also a handle approximation? I think so. Okay, let me have a look at this code. Just this is the whole detection that I have. Okay, I want to look at line 611. Huh? Oh. Yeah. Yep. Okay. So this function does call find extreme. Then notices that it found that extreme. We are already there. The absolute step is almost nothing, so we're on top of it. And then doesn't do anything except set the state to local extreme. I think that might be enough. I mean, I can or I have to call this function again, apparently, the find extreme. But I don't think I have to do that here. Let's not do that here. So instead I'm going to rely on the fact that the state was set to local extreme. And then we return, and then we get yeah, then we get here. So that is this line 69. It says do not return a value that would replace the current sample. The W was already updated. The last sample in the history is this. And if these are too close together, then I don't want to return that. But then what we do is immediately call handle local extreme. And that goes wrong, I think, because that assumes that damn it. No, I don't know if we even entered this point. I think we did, yeah, of course, we probably did. The step was like 10 to the power minus 8. I'm wondering if it is necessary to call find extreme again if this is not the case. I think I should temporarily remove negligible from the whole code. See if it then works. Suppose negligible is always returning false. So this now is false. And now we're simply returning that value without doing anything else yet. hit a space here. Fuck it, stepped over it. Well, anyway, it didn't crash. The last call is still a minimum. Minimum reached, and now we entered it again. And still looking for a minimum. That's ridiculous. Hey, what? So confused. No. Yeah, minimum reached. Yeah. So, where's my toggle? What the F? Now it's toggling it here. But I don't see another call to find extreme. Okay, that should become after the toggle anyway. It's returning minus 12. It still didn't toggle. Sorry, it still didn't call find extreme, I mean. Yeah, insinuations getting tiresome, Boss Bunny. I hate GDB. At any rate, it did not call find extreme again. So still core dumping in the end. You mean you're not insinuating anything? In that case, you're just talking 100% nonsense, I guess. You know, trying to do serious C++, and then you come with weird remarks like, Minimum reach, heck yeah. I mean, as if that is exciting. It just doesn't make any sense. Very random. Quite extreme. Minimum reach. There was a reason why I had to call this earlier than normal. I forgot where or why. Reaching a goal that took me 2 months would be worthy your reaction. But this is just the algorithm, which took 10 microseconds to reach it. So yeah, it's just normal. It can do it a million times per second. So it's not exciting. It is more an event, a state almost. It's a state change of the algorithm. On a very short time scale. I can't wrap my head around this, as usual. Okay, I guess that what I can do is invalidate something at the moment we get here. So find extreme, changes region out, and extreme type. Of whatever is being passed, and that is then last region and next extreme type. in all cases, I think. Here too. I think there's only 2 of them. Okay, but it's a different test. Yeah, so what I could do is here invalidate those 2 things. I can't invalidate next extreme type though. Nope. So we can. The only thing I can invalidate is the other one, which was the region. Yeah. Yeah. So last region. I guess I could set it to unknown here. Maybe that will work. I'll play what? Region, of course. Yep. And then hopefully we assert, because then it's going to say, hey, wait a minute, my region is still unknown. Well, I need it. That would be nice. Well, it's a different assertion. Not exactly what I wanted, but no. If this fails, then apparently we even have to call find extreme in this case. That's exactly what I wanted to see. We still need to call find extreme. But why do we get there at all? 24 degrees. Yeah, I really want to know or remember the ha-has if that's gonna happen. Why I needed to call this find extreme in the first place. I remember I moved it like up because it was needed before something else was called. Especially the last region, no? Maybe we just look at where that is being used. I might remember it again. It's being used in a billion places. Oh, now first call suddenly. Oh, I fucked that up. Okay, so that is happening now. I mean, that's why I got a different assert. I changed the last region back to unknown, therefore it looked like a first call again. Well, in a sense, maybe it is a first call, but nah, no, it's not. Or is it? It's dubious, is it? Well, actually. Yep, that variable name first call is really bad. Doesn't explain at all what it means. This is like the opposite. The opposite. So I'm invalidating last region by setting it to unknown with the result that first call is set. And my wish is then that as a result of that, I will call find extreme. And then here I get okay, I lost it. Yeah. We get if it is set, then find extreme is already called. Huh? So apparently that was, yeah, I moved it out of here, I think. So that is kind of a hack here. It abuses first call, knowing that this function is only called from a place where before that we called something else, which if first call was true, we'll call find extreme. That's not object oriented. That's just, you know, doing something elsewhere and then hoping here that it was done. But assuming that the comment is correct, between. Yep. Okay, so this by definition not true, because this would be the call. If first call is true, then this would be that call, but that says, that asserts that new extreme type is still unknown, and it isn't in my new case, so not true. So we can't do this. I can't invalidate it by setting that to unknown. Then maybe I should just immediately call. I don't know what to do. Jam it. Okay, I'm going to use big guns. Invalid. Totally new value. Hmm. But what to do? Fire first call. No, I really have to understand what first call means. What exactly does this mean? This call is passed to handle approximation. And it is set. It is reproduced rather from last region, because if it's true, if last region equals unknown, and here again inside a function, and then we test here being used. I'll ignore a search. This is then the function where it was passed to. And then we go to the top right. Yeah. So it's passed to handle approximation and used here. That's it. I think that number of relevant samples on approximation can only be 0, 1 or 2 because of how it is updated. Yeah, that's the number of relevant samples in this array. So it can only be 0, 1 or 2. And the cubic approximation is only valid if you have 2. It's 0 after reset. And I think this increments it. Add. Approximation add. That it is already not 0, larger than 0, or it is set to 2, or number of relative samples plus 1. So it's either set to 1 or 2, or left at 1 or 2. Yeah, it's set again to 1. So it's set to 1 or 2, which means that if it is unequal 1, then it must be 2. because it's not 0. I think I should use equals to, because that's kind of the signature of having a valid cubic. And I think find extreme just needs that. So here first call more or less means that make sure that if this is the approximation on the stack and not in a local extreme, and we have at least 2 samples, then make sure that find extreme is called. And then it is also passed to handle approximation, which is kind of weird because I refused to pass it to the other one. Might as well have passed it here, but I didn't because I could choose it like that. Or do you think that maybe last region is already set? That's possible, I guess. So then the call to handle approximation. That happens here, and first call is passed. Yeah, because that is after the call to update approximation, which might call find extreme, which sets last region. Sorry, yeah. Therefore, cannot reconstruct the first call from the value of last region because it might have been changed. So that's why it's cached here, and then we just pass it to handle approximation. And then first call is going to be used as just in that if. Is that all? Seems so. Well, this is not true. This is only true if approximation is on the stack still and not a local extreme. And you have 2 samples. Okay, so suppose we have only 1 sample, then what happens? Well, then we go here. and return there. So if we get here, then we do have two samples. That's one thing. I guess it cannot be a local extreme on the very first call. So if this was true, then we also know that it's not a local extreme. Therefore it was called. So I think the comment holds in this case if I don't touch it, if I don't touch the code. And it really should be true just once. I should not invalidate the region, I think, it seems. But. It should be safe to call reset though. Let's see, a reset on algorithm. So no reset on algorithm. Penalty not. Reset on approximation. Debuggable. Not really. There is no function reset. Yet. So, do something. Getting tired again. It's the first call. Okay, so I think we have a minimum, and we don't approximation. I mean, if you have a minimum, we don't see where to jump, so there were no the fourth degree polynomial didn't have any extremes, so we didn't jump anywhere. So we just continue in the same direction, uphill. And that means that we stick the new sample then just belongs to the last approximation. The approximation that belongs to the local extreme that was just found, the minimum. So we add new samples while going uphill to the approximation of the local extreme, which increases its scale. So it's not the first call. We just keep adding new values while approximation is no longer, is actually a thing that points to the stack. Not to the stack, to a local extreme. Yet, I do need a maximum for some reason. No, I don't. See, I invalidated it just to stop myself from using the returned values. But why? Oh, because I already found it. Aha, yes. Why am I calling handle approximation at all then? This is an approximation that belongs to a local extreme that we already found. Just to increase the scale? Or was that already... Has that already happened? I don't think we should even get here. Should not get here. Handle approximation should not be called, which means that in terms of the meaning of first call, it doesn't really matter anymore, because I'm not going to call this. Okay, I think this assert should be removed. It seems okay to enter again while it is still invalid. And then first call should be false because it is not first call. Well, for now it's okay to make it false, I think. And then see where we need that thing not to be invalid. So then I call update approximation with the new thing, which is going to do the same thing, isn't it? Though we get here again with again unveil, but it's the same thing. That I just have to edit this because of that, but it's a duplicate. So again, this is now false. And then we get here, and this is not true. So we skip over that. And then we call update local extreme scale. Let's call this scale update. Why am I on reset now? Extreme is true here. Kinetic scale. Oh. Yeah. Local extreme is true. Type is not none. If not local extreme, but it is, so we get here. And the cube is still the same, that is correct. Not saw more than 2 relevant samples. I think we did, definitely did. Current relevant samples, current index, do some assert, it's still away. So this is going to be false. Then assert false is unequal local extreme, which is true. Yeah, that's also correct. Okay, so the thing is inserted. It's inserted in this case at the back. We don't get here. If local extreme, yes. Do we have a fit? I don't know. Maybe not. No, we don't have a fit, I think. Wait a minute, where did I jump to? -12, oh, then we do have a fit. do we get here? Whatever. Left index, okay, it's included. Now we still have to call calculate the value. It's not done. Now value is calculate value. So local extreme, yes. Away from CP, everything is correct. Didn't do much though. That local extreme didn't do much. Not a first call. The first call is false. So it is already correct then. We don't do disconnected, plus it wasn't disconnected. So I get here, which then draws it. Exclamation is that. Return new W. Okay, something is wrong. I didn't update this at all yet, I think. Let me add a magic value for an uninitialized W. Stuff fit in a double. It's a bit. It's 20 is maybe a bit much. Let's keep it at 15 or something. So let's say 8 on both sides. This is more chance to fit. Print that. Nope, that doesn't fit. 8, 7, 6, 5, 4, 3, 2, 1. There's an additional one there. Yeah, can't have everything. Maybe like that. I'm not convinced. Well, maybe it doesn't matter. I mean, I'm just using something, this for example, assign that to a double, and from that moment on it's exact, of course. Then that double is just whatever it is. It might be that, but... Okay, so I just pick something. Could add a 1 here just to make sure that everyone understands that. Well, no, I don't know. Something, and then this is my uninitialized magic now, and I can then use that here. Yeah. And that's only really necessary then when debugging is on. So see, debug only. Oh, I see magic doesn't exist. Yeah, and then this is again necessary for a search. Probably do it like this. FCW debug. Right. Hmm. Uh-oh. The very first call. So this is being entered and then it tries to return something that is uninitialized, really. You have just a single sample. Right. Yeah. Okay. Basically, it's okay to return nonsense if we have only one sample, because that's being tested afterwards. Kind of stupid though. Oh wait, yeah, now I remember. It's not. It's uninitialized is good. It's okay. It's allowed to do that. It's the problem only occurs when we actually try to use that value. I think that's how I designed it. So I can. This is not true. Can return whatever it wants. But I have to test update approximation. At least, I mean, update approximation. So what that is being called. Gradient descend algorithm. Double double new just one line word is being called. The only line word is called, yep, correct. It's just passing that value. It's just passing it. Oh, there's another one. Okay, how do I test if approximation pointer is on the stack? No, current approximation of algorithm. It's rather not first call, or it's on the stack. Which means that after this test, well, we can't have zeros there. It's not so. Here are two symbols, so therefore now new W must be valid. Or is it? I could test it here, or maybe later inside handle approximation. I could still test it together with the first call then, yeah. Yeah, well, I mean, yeah, if first call is set, don't even have to test that. So here I'm using new W, I'm printing it, which is kind of stupid. Okay. Is unequal, initialize the magic, was it? Apparently. sort the two samples that we have so that one in the direction of is lost. Wait, what am I doing? Yeah, so if first call is set, then it can no longer be uninitialized. And then we are going to use it as well. Or not. Well, yes, still inside this block here. On here it's initialized by something else. You know, at this point it should always be initialized. I think then we finally have an assert that can go wrong. Interesting. Call find extreme before getting here, and the very first thing that we do is call find extreme. No, the whole assert is bullshit then, right? Although I'm setting previous region here. Why is that? We really shouldn't change our amount by the direction. Last region equals previous region. Oh, or, sorry. But still. Testing last region again here. That might be set. That is set. Last region must be in between, or it must equal to the previous region. That's not true. If I invalidated that region, which I did, here it is invalid, right? Basically, you can say we changed our mind because we started over. Yeah, I don't know. Let's just put here previous region. equals invalid. If the region is invalid in this case, then we are not changing our mind, in my opinion. Trying to wrap my head around what exactly could happen. Find extreme is only trying to find a totally different extreme. It could definitely be it's random, right? Yeah, so this whole assert is then nonsense. What to do in this case? Next extreme type is unknown. Yeah, the thing when I added this here, I actually meant that it is left or right. I know I added invalid, so that gets into this point as well. If the last region is invalid, should we even get here then? It is kind of the same. If it is valid, it is kind of the same as this call, isn't it? Don't tell me I don't have it. Oh, that's the one that already happened. And you really want me to do that here? No? Well, completely forgotten why it was done before this point. Why was it done before this point? I cannot remember that. I think there was something that is being called after cubic initialize. That was the reason. So let's search for that. Cubic dot initialize, I think. That is the line that I was looking for. So this that returns immediately. It's approximation add. Yeah, and the caller then did something for which it needed it, and then it calls the next one, which I don't know, update skill maybe. Oh, we can find that back. If I can find the call to add. So it's somewhere I'm calling add, probably like this. No, probably like this, or not. Actually, I think I support this. I don't. HTS. Totally not supporting that. Well, I have an approximation add here. Yeah, and then update skill happens afterwards. And then this is what is happening in between. Which is the call to find extreme. What? No. Okay, well, find extreme. Oh, that, I guess find extreme must happen before the call to update skill then. Yeah, because that is being passed next extreme type. What about the other one? Comment it out. Great, great. But at least we'll insert here once we get there. This is never returned anywhere yet. Building it one little piece at a time. Add stuff. This is the stuff. But yeah, I guess here's what I want to find back. So it's more like we need to call find extreme before calling update skill. So why not just add, and update skill doesn't know anything about last region, so I can't test if last region is invalid or not. So just about next extreme type then. Okay, then it doesn't matter when I call it. Perting. Which is a good thing. Well, actually, it still has to be called. So I need to know when this is being called now. And then realize or make sure that find extreme was called. Relatively recently, like this. Update skill on approximation. GS update skill. That's the only line. Great. That's a sign of good programming. Certain stuff only happens in a single place. Nevertheless, yeah, okay, well, that would be then the case. But now it's possible, of course, that we do this and then not do this, because we only do that the first time, so first call is going to be false here. And then call that anyway, while next extreme type is not set. Well, we'd already toggled it. So I think that's totally fine to call this without calling find extreme in that case. But then it must be called later, as in first call was not true. And this is okay, because we're only using next extreme. And then returning from this function, which is update approximation. And everything's in this file, isn't it? And then I can ignore this, and then we get here, and then we call handle approximation while first call is false and find extreme is not called yet. So this is false, and then the find extreme is not called yet. So yeah, last region is invalid. Now I think this block was written for last region being not in between, but being defined, not invalid. So this must be really like it's equal to left or right. However, if it is invalid, then I just want to call find extreme as well. Can I hijack this? Probably not, because this is being returned. I think I'm getting there. We're getting there. Okay, I could make this acceptable, but it looks a bit weird. So let's just swap it with this one, exclusively to make it look less weird. So if it is in between, then I really need to write new code, and otherwise it's just left, right, or invalid. And we don't care. We just call find extreme. Period. Invalid or left or right. And then this assert has to check on invalid, but well, that's just debugging code. However, now this can happen apparently. So I need to write this code now. In which case it's no longer an extreme jump, I think. No, it's not. That is, what is new W set to if next extreme type is unknown? I guess it's set to nothing. Find extreme. Setting next extreme to unknown. What is extreme type? Well, it sets it to unknown here, for example, and then returns bullshit. Wait, what did I want to know? Yeah, new W is, I mean, if this extreme jump is set, then that this must be a jump to an extreme, which is definitely not the case if the next extreme is unknown. So maybe you can do something like if next extreme type is unequal unknown, then do that, otherwise do something else. And I could add a assert here that new must be initialized, but well, we do that immediately afterwards anyway. I would almost turn it around and say it must still be uninitialized if we get here, but well, don't have to test that. I'll just set it to something. Yeah, I think new W is something. This has to be written, and I think I would like to play chess now. Yes, so Anup. Can you challenge me? Because I'm way too tired to code now for a moment. Let's have a break. So yeah, can you challenge me? My handle is TimmySB. And we are on light chess. Hello, IDK. You know what? I'll play a game against someone else, and then afterwards you have challenged me, right? That will just hang here anyway. So challenge me, and then I'll see it after this game. Maybe you're still going to. anyway. Yep, the old Sicilian. The old Sicilian. The old Sicilian. The old Sicilian. And now I'm out of theory, really. Sort of. That's a good move here. So black wants to push this pawn, and if I do that immediately, take, and I lose it, so that's not good. I could put my bishop here, then he could pin my knight, and he can play my other knight here, and then he keeps the pin, and then I play this. And then he will probably exchange here, and then take back with the knight, and then I'm threatening to push. But then that was a one extra move for him. So I'm gonna assume he just moved the bishop out. That's gonna work, isn't it? So let's threaten to push it. See, he just plays the bishop out. Not even here. This guy doesn't understand this opening. So now I push, take, and everything is okay. Well, why not immediately? So black is okay now because yeah, I got to push that pawn. Not that we are winning, but definitely we're going to make a draw here, as it were. Yeah, let's just take like this. I'm not sure though. You could push this pawn. I go away and I lose my castling. But on the other hand, I can take here. If he would do that, then the rook goes here, and then my bishop can go, say, all the way back, and then I lose my castle. But the queens are off the board as well. This pawn is defended, and I'm one pawn up. Am I really? He's going to attack my bishop again. Oh, it's protected by my knight. I don't know. I'll see. I think this is okay. Yeah, and he doesn't even do it. So let's now protect my queen. That is going to take, unfortunately, 2 moves with the castle. I can protect my queen like this. Yeah, no, you're too late. I mean, you can take it, but I just take back with the queen. And I'll block my knight. Is that a problem? Maybe I should have gone here. Yeah, well, maybe not. I don't know. Then this diagonal becomes a little bit weak. Yeah, I see your challenge, I think. This is Anup. I'll play him afterwards, or her, or it. Okay, just him. Let's slightly behind in development, I must say, but yeah, I'm definitely. I'm not having any advantages really. Well, Moscow also. I have the feeling that I'm worse. Well, let's ask the computer afterwards. No, I'm gonna play a noob, so no analysis there. Did I give something away? No, I didn't. Wait a minute. No, it just goes there. On my half. I'm like, what are you doing there? This is my half. Yeah, those are nasty moves. I can't develop my knight now. That's definitely the case. Let's do this one then. And now I can develop my knight and defend my pawn in one step here. See, it's beautiful. Thank you for going away. And then we can develop this rook. I don't like the looks of that though. How about I just go here? I should push his pawn, right? I mean, just asks to be pushed. Nobody knows why he plays this. Absolutely nobody. I'm still going to push this pawn though, because it looks good. I should put my other rook here. Oh, that's why. Well, okay. I can defend it. Checking my bishop. Well, I can't move my bishop anywhere else, I have to admit. And then my knight would be attacked. Could go here, but that doesn't help me. I could just move my knight away immediately. Yeah, I'm not good, I think. You could just take and then I take back and then he pins my knight on this rook and he takes this as well and then his rook can come in here. Unless I move my rook here maybe, but then he could come in here. No, he cannot because of this bishop. I don't know, it's dubious. No reason not to go forward. True, very, very true. Very true. I don't want to lose a rook. I think I have to take it. I don't know. Let's just take it and then take here. Or not. Do I take there? It's unclear. It's super unclear. He wants to double his rook, and I'm running out of time too. Let's not make weak pawns. With this little time, I just have to start to move very quickly. Very quickly. Nasty. Can go there, however. there. Okay, I don't get that one. Maybe he wants to go here. Is that a problem? Yes, that is a problem. Shit. So we exchange here, and then he goes there, and then I don't... I can't defend this point. So I'll have to... Oh, he's not doing that. Yeah, I can just do this, I guess. Oh, it takes that one. That's a good one. I have to admit that. Oh, and he takes that one as well. No. Why? I was a bit confused. I should have taken the bishop and then takes my... Yeah, I guess I'm just running out of time here. That was the problem. Well, at the very least, I'm getting a pawn back. No, I'm not. Asshole is attacking that. He's attacking my knight. And I have only 30 seconds left. Yeah, I was hoping you did it. Actually, let's go here. Oh, yeah, no. Beautiful. Beautiful. Anup. Oh, how does it work again? I have to click that. It worked. Anup, are you still online? Anup, yes, Anup is online. Okay, bling. You have 20 seconds. Okay. Yeah, let's castle short. Good idea. I have the feeling I'm going to move this knight. Let's move it here. Now I have the feeling he's going to give away a queen. Yep, he gives away a queen. And I do not really have to take it yet, right? I can just go here. No, take a queen. That is not necessary. Okay, let's see. Let's take the queen because why not? And then we don't have a mate to take anymore. There's a new knight here. It goes to the same square. Yeah, it would be. See, it looks like quality, but it isn't. I'm going to. What about a first take here? No, I cannot do that. I have to push my pawn. Taking my rook. Yeah, okay, let's move the rook. Let's move the rook again. I don't want to say much, but that was not a very good move, of course. As if there was any other good move, but opening this file for my rook. Oh my god. This is so mate, you know? This is mate. What are you going to do about it? That, yeah, very good. Mate. It didn't work, Mr. Nip. You want to be beaten again? Rematch. Oh no, now you have white. Casual. It's not even rated, this. Well, that means I can talk more. It's not rated. I developed my bishop. Yeah, I gave it away. Let's do this because you have too much weapons aimed at e5. And now I have two. Okay, I could do this. You attack me. That's not nice. This is another option. Definitely another option, but nah. Man, what should I do? Tick, 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 tick. Nothing is nice. I just developed this one. Nothing is nice. Is that not a piece? Do you give away a piece? I think you gave away a piece. Let's see what happens. No, you don't give away a piece. No, nonsense. He just goes there, and then yeah. least it costs a bishop pair. Actually, maybe it doesn't. Unless I go back all the way here. Oh, that's just great. That is just great. 34, that's not working. I'm gonna go back. So, but I'm going to take your good bishop. Now wait a minute. Now wait a minute. What happens if I put this in between? Or this? I'll lose this thing and then that's no problem, is it? But it's my good bishop and this is your bad bishop. Okay, well I can put a knight in front of it then. If you exchange that, that's not too bad. The knight is going there, okay. My castle. Let's kick the knight, because I want to. Oops, that wasn't the best move. Oh no, it wasn't. Not because of that reason though. Yeah. That doesn't feel good. That does not feel good, meneer Noob. Mr. Sir Noob. No. What are you doing now? You're giving me a queen and everything. You're so dead. Let's begin with check. And then he goes here, I bet. Is he going to be that? No, he's not that stupid. Yeah, okay, this is the threat, of course. I'll just take the bishop first. Well, now you can do something about the rook. That is true. It's not doing something about the rook. You got a point there. You're gonna take my knight, or just going to take my knight, isn't he? But okay, I don't care. Let's block this dangerous pawn, give away my knight, and get a rook. The rook is mine. He saves the rook, okay, totally possible. Let's go away. No, let's go away with this one as well. That's not doing anything. Let's take this one. Oh, but now it's doing something. Okay, for yes, because I took the ball. Right. Okay, annoying. Still 5 points up though, so I shouldn't despair. Except for the time, of course. He's very aggressively attacking my king, right? It's probably possible. Nope. Jack. Okay, now exchange queens or do something like that. No, I'm just gonna take it. I'm really lame. I know I'm lame. I know it. And I'm even using my other rook. Massively lame. Yeah, with tempo. My king wants to go forward. Didn't you know that? What kind of move is that? What kind of move is that? Checkmate with a pawn. Oh, nope. Oh, horrible. Yeah, that was just the last move. You could have avoided the pawn, mate. Yeah. And I'm gonna game over here as well, because let's get a real break. Maybe another walk. It's still pretty nice weather outside, I think. So it's 8 p.m. I should eat. Okay, I'm gonna eat dinner. Bye bye.